Hey everybody, Mr. Gajewski here, and today we're going to talk about solving absolute value inequalities. So let's go ahead and let's take a look here at our first example. The first two are going to involve less than symbols. So the absolute value of x plus 3 is less than 12. Let's go ahead and solve this like we normally would. So we'll subtract 3 and we get the absolute value of x is less than 9. Now, if you remember when we solved absolute value equations, we had to rewrite two cases of each equation. We're going to do a similar thing here with inequalities. So I'm going to drop my absolute value bars, and I'm going to rewrite this as x is less than 9 and x is greater than negative 9. So just like an equation, I'm going to flip the sign of my expression, but I'm also going to flip the symbol of relation. So now I have two simple inequalities. I'm going to go ahead and I'm going to graph those. So I'll zoom out a little bit here. And what is this going to look like? Well, the smaller number is negative 9. And the larger is positive 9. We're going to graph both of these. So greater than negative 9. So greater than, it's going to be open, shaded to the right. And for our other simple inequality, we have x is less than 9, so less than, that's open, shaded to the left. So if you recall from our lesson on compound inequalities, we have two inequalities here. Two simple inequalities make a compound inequality. We have either an and statement and graph or an or statement and graph. So these are overlapping statements. This is actually an and compound inequality. So we can write this, our solution, as x is greater than negative 9 and x is less than 9. We could also write it as negative 9 is less than x, less than 9. And below is our graph. So either of these would work. This is an and statement. So when we have a less than inequality with absolute value, we will end up with an and statement. So less than gives us an and inequality. Do another example here. So the absolute value of x plus 4 is less than or equal to 2. We're going to go ahead and, well, we've already isolated the absolute value expression. So we can go ahead and rewrite two cases here. So that's going to give me x plus 4 is less than or equal to 2. X plus 4 is greater than or equal to negative 2. Go ahead and solve both of these. And I'm going to get x is less than or equal to negative 2. Ooh, forgot the equal to sign there. And then we have x is greater than or equal to negative 6. And again, this is less than or equal to. Let's go ahead and graph. Negative 6, negative 2. All right. So this will be, well, at negative 6, it's greater than or equal to, so that's a closed circle shaded to the right. And at negative 2, it's less than or equal to, so it's going to be closed and shaded to the left. So again, if we have our less than symbol or a less than or equal to symbol, that means we have an and statement, and we should write our final answer here as x is greater than or equal to negative 6, and x is less than or equal to negative 2. Well, what happens when we have an absolute value inequality with a greater than sign? Well, let's take a look. Let's isolate the absolute value term. So I'm going to add 20 here, and I get the absolute value of x is greater than 7. We're going to rewrite two cases. X is greater than 7. X is less than negative 7. So what is this going to look like? Let's go ahead and let's graph. So negative 7 and 7 are our 2 points. And at -7, we have an open shaded to the left. So it's less than, and it is shaded to the left. How about x is greater than 7? So greater than, that's open and shaded to the right. So this is an or statement. We have two diverging solutions here. The arrows are going to the left and the right. They're going away from each other. It can be in either this section or this section. So we have an or statement. So let's go ahead and let's write that. X is less than -7, or x is greater than 7. Go ahead and circle that up. Let's do another example with greater than. So let's isolate the absolute value expression. The absolute value of x minus 8 is greater than or equal to 6. Let's rewrite two cases of our inequality. X minus 8 is less than or equal to -6. X minus 8 is greater than or equal to +6. Go ahead and add 8. X is less than or equal to 2. X is greater than or equal to 14. And if I wanted to graph this, well, I'm going to pick the smaller numbers. So 2 is going to be on the left. 14 is going to be on the right. This is going to be, well, at 2 we have less than or equal to. So equal to shaded, less than to the left. Okay. For 14 we have equal to, so we're going to fill in our point. Greater than, we shade to the right. That gives us our graph for greater than. So this is an or statement again. So we should write x has to be less than or equal to 2, or x has to be greater than or equal to 14. So quick recap. Absolute value less than, that's going to give us an and statement. Absolute value greater than, it's going to give us an or statement, an or compound inequality. We're going to take a look at two more special case inequalities involving absolute value. So my fifth example here, the absolute value of x minus 6 plus 7 is greater than 2. So let's go ahead and let's isolate the expression of absolute values. So x minus 6 greater than -5. So now I need to think about this. Some number subtracted by 6 greater than -5. So the absolute value of some numbers minus 6 has to be greater than -5. Well, when I think about absolute value, whatever value I get here, when I take the absolute value, that's going to be a positive number. So a positive number greater than -5. Well, I can plug in any number here for x, and no matter what that number is, when I subtract 6 from it and take the absolute value, I am always going to get a number that is greater than -5, because the absolute value will make it positive or 0. So in this case, because it doesn't matter what I substitute in for x, I'll always get a true statement. So in this case, we are going to say that our solution is all real numbers. So all real numbers. Or we can write the symbol. And just to see what I'm talking about here, let's plug in, 100. Well, the absolute value of 100 minus 6 greater than negative 5. Well, I'm going to have the absolute value of 94. Well, 94 is greater than negative 5. Let's go ahead and let's plug in a negative 100 minus 6. Well, that's going to give me the absolute value of negative 106. What is the absolute value of negative 106? That's going to be a positive 106. And yes, 106 is greater than negative 5. So as you can see, it doesn't matter what number I substitute in for x. I will get a true statement. Thus, we say all real numbers. Let's do one more example for this lesson. Like any other absolute value inequality, let's go ahead and let's substitute isolate the absolute value expression. Negative 6 plus 5 is negative 1. All right, the absolute value of a number plus 12 less than or equal to negative 1. So what number can I plug in x or 4x, add 12 to it, and get an absolute value less than negative 1? Well, we're going to run into another problem here. Well, no matter what number I plug in here for x, when I take the absolute value, I'm going to get a positive number or 0. And I want to know what positive number or 0 is going to be less than or equal to 1. Well, if I think about that on a number line, okay, absolute value is always going to be positive or equal to 0. But I want to know what's less than negative 1 right here. Can you see what we're looking at here? We have no solution here. There are no solutions. It doesn't matter what number, no matter how big or how small, you substitute in for x. When we take the absolute value, we get a positive number or 0, and a positive number or 0 will always be greater than a negative number. So the absolute value less than or equal to a negative number will yield no solutions. Or the symbol, go ahead and circle that. And again, if you're not sure, go ahead and plug in a number here. How about 100 again? Well, 100 plus 12 less than or equal to negative 1. The absolute value of 112, it's 112. Is 112 less than or equal to negative 1? No, that is false. Let's plug in a negative 100. Well, when I do that, I'm going to get negative 88 less than or equal to negative 1. When I take the absolute value, I get 88. Is 88 less than or equal to negative 1? No, that is false. So again, you can see here that no matter what I substitute in for x, I'm going to get a false statement. So there's nothing I can do that's going to work. We're going to say there are no solutions. So that's a brief overview on solving absolute value inequalities. Let's do a quick little recap here. Absolute value less than a positive number or 0. That is going to give me an AND statement for my answer. Absolute value greater than a number 0 or positive will yield an OR statement. Absolute value greater than a negative, our solutions are all real numbers. Absolute value less than or equal to a negative number, and we will yield no solutions. That's all for now. If you have any questions, let me know. I hope that helps, and I will see you next time.